Good day, ma'am. Once again, it's me, BLESSY ATIS again, Ilajas from BSEE 1A. And this is my output or my explanation on how I derive my answers from the problem set given. So, lecture 1, heat transfer, problem set number 1. Example 1.10 on page 39 to 40. Calculating heat transfer through conduction. A polystyrene foam icebox has a total area of 0.950 meters squared and walls with an average thickness of 2.50 centimeter. The box contains ice, water, and canned beverages at 0 degrees Celsius. The inside of the box is kept cold by melting ice. How much is ice melts in one day if the ice box is kept in the trunk of a car at 35.0 degrees Celsius? So, from these questions, kanang nag-involve siya both heat for a phase changes sa melting of ice and kanang pag-transfer sa heat by conduction. So, to find or mapangita na to ang amount sa ice melted, pangitaon na to ang net heat transferred. So, this value can be obtained by calculating the rate of heat transfer by conduction and multiplying by time. So, these are the given. So, K or the thermal conductivity is equals to 0.010 watt per meter times degrees Celsius. So, this is the polystyrene foam. Dayon, the average thickness of the walls is equals to 2.50 centimeters. So, ato siya i-convert sa meter. So, it will become 0.0250 meter. So, dayon ang atong kuan kanang temperature sa cold in which is equals to 0 degrees Celsius. Dayon ang heat temperature is which equals to 35.0 degrees Celsius. Dayon ang atong area in which the total area of the polystyrene foam ice box kuan kanang 0.950 meters squared. Dayon ang ato ding time is in one day, so gi-convert into hours, so 24 hours. Dayon gi-kuan siya into seconds in which it is 6,400 seconds. So, solution. So, since nakuha na to ang mga na-identify na to mga given value, so we need to solve for the mass of the ice M. So we also need to solve for the net heat transfer to melt ice or the Q. So the rate of heat transfer by conduction is given by this formula, in which the rate of the conductive heat transfer, in which kani where the P is the power of rate heat transfer in watts or in kilocalories per second, then A and D are its surface and thickness as shown in sa kuan sa 1.22. So ang kuan TH, which is the heat transferred minus the cold heat temperature minus sa kuan kanang cold temperature. So mo na siya ang temperature difference across the slab. So then ang K dayon is the thermal conductivity of the material. So mana siya dayon. Then ato na din i-substitute, in which ang atong thermal conductivity is equals to 0.010 watt per meter times degree Celsius times atong kuan din atong area kani siya 0.950 meters squared times ang atong heat temperature, in which 35.0 degrees Celsius, dayon minus kuan kanang cold temperature, in which 0 degree Celsius. So kuan na yon over ang diameter niya sa kuan kanang average thickness, in which 0.250 meter. So P is equals to 13.3 watts. So para kuan kanang ma-calculate na to ang ice melts in one day of the kung ang ice box is kept in the trunk of a car, so need na to siya i-multiply multiplying the rate of heat transfer by the time in which ato siya gi-convert into seconds. Dayon, so we obtain kani nga formula. So P in which ato na siya nakuha ganina P times time. So substitute, so ato nakuha na ganina is ang P 13.3 3 din siya, sorry, 3 na siya. 13 so 13.3 basta ka siya 13.3 watts times kanang ang atong time in which we convert ito into seconds is 86,400 seconds. Dayon simplify, so 1.15 times 10 to the 6th power joules. So we set this equal to the heat transferred to melt the ice. So Q is equals to M Latin heat fusion and solve for the mass M. So kala siya, then 1 is equals to 1.15 times 10 raised to the 6th power joules over 334 times 10 raised to the 3rd power joules kilogram over kilogram. Dayon makancel na yung joules kana makancel, so simplify. Dayon we can now arrive the answer in which 3.44 kilogram. So therefore 3.44 kilogram is the ice melts in 1 day if the ice box is kept in the trunk of the car at 35.0 degrees Celsius. So let's proceed to the problem set number 2. Example 1.11 on page 41 to 43. Two conductors end to end. A steel rod and an aluminum rod, each of diameter 1 cm and length 25.0 cm, are welded end to end. One end of the steel rod is placed in a large tank of boiling water at 100 degrees Celsius, while the far end of the aluminum rod is placed in a large tank of water at 20 degrees Celsius. The rods are insulated so that no heat escapes from their surfaces. What is the temperature at the joint, and what is the rate of the heat conduction through this composite rod? So the heat that enters the steels from rod from boiling water, wala siya place nga para mugawas bitaw through the steel rod. Pero pwede siya sa aluminum rod sa cold water. So we can equate the rate of conduction through the steel to the rate conduction through the aluminum. So these are the given values from the problem set or the question. So identify the knowns and converted them to SI units. So the length of each rod is equals to 0.25 meter. So the cross sectional area of each rod is equals to 0.85 times 10 raised to the negative 5 power meter squared. So then ang the thermal conductivity of aluminum is 220 watts per meter times degrees Celsius. Then the thermal conductivity of steel is equals to 80 watts per meter times degrees Celsius. So the temperature at the hot end is kanang 100 degrees Celsius. Then ang temperature at the cold end is equals to 20 degrees Celsius. So solution. So para makalculate ang heat conduction through the steel rod and the heat conduction rate through the aluminum rod, so we must use this formula. So actually sa kanang dato sa book is duha ka method ilang gigamit. So direct current circuit o kang thermal resistance. So una sa ta diri sa direct current circuit. So P steel is equals to K steel A steel times change of T steel over L steel or the aluminum steel. Then kanang distribute. So ang atong thermal conductivity of steel is equals to 80 watts per meter times degrees Celsius. Dayon ang the cross sectional area of each rod is equals to 7.85 times 10 raised to the negative 5 power meter squared. Dayon ang kuan dayon sana ang the temperature of the at the hot end is equals to 100 degrees Celsius minus T. So over ang kuan over sa kanang the length of each rod is equals to 0.25 meter. So simplify is equal to 0.0251 watts over degree Celsius times 100 degrees Celsius minus time. So ano siya? So to find sa kuan P aluminum, we must use this formula. So thermal conductivity of aluminum times the cross-sectional area of each rod times the change of T aluminum over the length of each rod. So the the thermal conductivity of aluminum is equals to 220 watts over meter times degree Celsius times ang cross-sectional area 7.85 times 10 raised to the 5th power meter meter squared times yan kanang ang T minus 20 degrees Celsius. So mo ni siya ang bali mo ni siya ang cold end, dayon mo ni siya ang hot end in which 100 degrees Celsius. So is equals to 0.0691 watts over 0 na degrees Celsius times T minus 20 degrees Celsius. So 0.0691 watts over degrees Celsius times T minus 20 degrees Celsius is equals to 0.0251 watts over degrees Celsius times 100 degrees Celsius minus time. So T is equals to 41.3 degrees Celsius. So the P of steel, so ang siya mo ni siya ang kanang the two rates equals para ma-solve ang unknown temperature. So mo na siya 41.3 degrees Celsius. Dayon para ma-calculate ang rate sa steel, so we must gamiton natin ni siya. So 0.251 watts over degrees Celsius times 100 degrees Celsius minus 41.3 degrees Celsius since nakuha naman nato ang T. So in which P steel is equals to 1.47 watts. So sa kanang other method dito sa gikuan sa book is kani siya. So R is equals to L over K, P is equals to A change of T over R, or the change of T is equals to PRA. So we know that the change of T steel plus change of T aluminum is equals to 100 degrees Celsius minus 20 degrees Celsius. So i-minus lang siya. So it will derive 80 degrees Celsius. So we also know that P of steel is equals to P aluminum, and we can denote the rate of heat flow by P. So combine the equation. So PR steel plus PR aluminum, so same na siya dire. So gikuan lang siya, gi-combine ang equation. So thus we can simply add the R factors. So now P is equals to 80 degrees Celsius over A times R steel plus the resistance of aluminum. So we must find the R from the known quantities. So R of steel is equals to 3.13 times 10 raised to the negative third power meter squared times degrees Celsius per watts. And sa resistance of aluminum is equals to 1.14 times 10 raised to the negative 3 power meter squared times degrees Celsius per watts. So we must substitute these values to find the P. So it will become P is equals to 1.47 watts. So same sa dito 1.47 watts, same sa ito na ganina kana siya. So now we can determine change of T from for the aluminum rod nabasa lagi from the aluminum rod or the steel rod, and this is to find T at the joint. So muna siya ang kuan sa T is equals to 20 degrees Celsius. So muna siya ang katong sa hot ay joke sa cold ay sa cold temperature in which 20 degrees Celsius plus kanidayon sa change of T aluminum is 21.3 degrees Celsius. So i-add ra siya, so it will become 41.3 degrees Celsius. So same ra siya sa same atong first method o second method. So kuan la ang nakalahin lang is lahi siya nga method gigamit. So let's proceed to the problem set number 3, example 1.12 on page 45. Calculating the flow of mass during convection. The average person produces heat at the rate of about 120 watts when at rest. At what rate must water evaporate from the body to get rid of all this energy? For simplicity, we assume this evaporation occurs when a person is sitting in the shade and surrounding temperatures are the same as skin temperature. So eliminating heat transfer by other methods. So based sa problem mo ni siya ang given ang heart rate of a person at rest in which 120 watts. So solution. So the energy is needed for this phase change in which Q is equals to mLV. Thus the energy loss per unit time is kani. So QT is equal QT. Q over T is equals to mLV over T. So ang 120 watts over is equals to 120 joules per second. So M over T is equals to 120 joules per second over LV. So i-divide siya sa LV. So ang LV or the latent heat evaporation is equals to 2,430 kilojoules over kilogram, or is equals to 2,430 joules per gram. So M over T is equals to 120 joules per second. Dayon ang atong LV in which kanang 2,430 joules per gram. So ato siya i-divide. We simply divide. So in which 0.0494 gram per second. So para mahimo siya minutes, so kung kay seconds man siya, so ato siya i-multiply by 60. So now we can derive the final answer in which the rate must water evaporate from the body to get rid of all this energy is equals to 2.96 gram per minutes. So let's proceed to the final problem set on lecture 1, heat transfer. So number 4, example 1.13 on page 49.50. Calculating the net heat transfer of a person. What is the rate of heat transfer by radiation of an unclothed person standing in a dark room whose ambient temperature is 22.0 degrees Celsius? The person has a normal skin temperature of 33.0 degrees Celsius in a surface area of 1.50 meter squared. The emissivity of skin is 0.97 in the infrared, the part of the spectrum where the region takes place. So as we can see, so these are the given values. So the ambient temperature is equals to 22.0 degrees Celsius. Then ang skin temperature sa tao is 33.0 degrees Celsius. Then ang ang surface area is equals to 1.50 meters squared. Then ang emissivity of skin is 0.97. So according sa book, so naingon daw nga Stefan Boltzmann equation needs only slight refinement to deal with a simple case of an object's absorption of radiation from its surroundings. So assuming that an object with a with a temperature T1 is surrounded by an environment with uniform temperature T2. So the net of rate heat transfer by radiation is this formula. So by the way, kanang baka basin kanang nag wonder mo nganong nakuan ni siya na ang T1 og T2 na lahi na siyang value. It is because kay kuan na siya kanang convert na siya into Kelvin. So kana siya kay Celsius man so gi-convert na siya into Kelvin. So munang na 295 Kelvin ang T2, then T1 is 306 Kelvin. So let's proceed. So kuan kanang QT is equals to the obsolete sigma EA times T2 raised to the 4th power minus T1 raised to the 4th power, where E is the kanang emissivity of the object alone. So in other words, kanang it doesn't matter whether the surroundings are white, gray, or black. So the balanced radiation into and out of the object depends on how well it emits the absorbed radiation. So the quantity P net is positive, that it is the heat transfer from hot to cold. So atong absolute sigma kuan kana ang value niya is 5.67 times 10 raised to the negative 3 power joules per second times meter cube over times key raised to the 4th power times ang atong kuan kanang ang atong surface area in which is 0.97 times ang anang usana joke lang. Ang atong kuan emissivity of skin in which 0.97 din ang atong surface area is 1.50 meter squared. Dayon ang kanidayon kanang atong T2 ug T1. So ang atong T2 in which kanang gikuan na siya into Kelvin, 295 Kelvin times raised to the 4th power. Minus ang atong kuan T1 is 306 Kelvin raised to the 4th power. So na siya simplify. So first ato ni siya multiply dayon makuan ni siya. So now we can kuan makakuan din ta makaget din ta og negative 99 joules per second. So ikuan siya into watts. So therefore this equals to negative 99 watts. So kanang anong na negative ni siya kay kuan naman kanang na-release naman ang heat. So na-transfer na bitaw ang kanang ang heat sa radiation sa kanang katong unclothed nakahukas-hukas na person. So katong nagpatong pag sana kanang pagtindog niya sa kanang dark room host na kanang ambient temperature niya is kanang kuan kanang 22.0 degrees Celsius. So therefore the kanang this negative 99 watts is the rate of heat transfer by radiation of an unclothed person standing in a dark room whose ambient temperature is 22.0 degrees Celsius. So that would be all. Thank you so much, and to God be all the glory. Bye.